So these next ones, 2 through 4. So for these, we're solving for the missing side length, or for x. Okay. Again, we still need to have these ratios handy. So what we want to do is focus on, let's find the acute angle that we have information about. That's angle A. I know angle A is 22 degrees. They really can't fit it in there because it'll be too small, but this one is 22 degrees. And then I'm going to label the two sides that I have information about. This side down here is the hypotenuse because it's across the 90-degree angle. And then this side, I know this side is the adjacent side because it's next to angle A. It actually runs into angle A, so it's next to angle A. And then this other one's the opposite side. I don't need to write down opposite because I don't have information about the opposite side, so I'm going to just leave that blank. But I have the sides adjacent and the hypotenuse, and then you want to look through which ratio uses the adjacent and the hypotenuse. Well, that's this one here. Okay, that's the cosine. That's the cosine ratio. It uses adjacent and hypotenuse. So we know cosine of this angle is the ratio of the adjacent leg over the hypotenuse. So when I set up my equation, it's going to look like this. Cosine of angle A, which is 22 degrees, is equal to the ratio of the adjacent side over the hypotenuse, which is 4.2. And remember, we've been solving these proportions a lot. What we need to do is make it look like a true proportion, where you have a ratio equal to another ratio. Cross multiply, and then you circle the one so you don't grab the x, and then you divide by this outside number. I won't always put divided by 1 into the calculator, but you need to realize this because one is not always on the outside, and I'll show you in a minute. And then we just type this in the calculator. You can use the Desmos calculator online, or if you have one of these calculators. Make sure it's in degrees. Cosine 22 times 4.2, and then divide by 1, and we get 3.9. Okay. Pause it. I'm going to move on. Let's recreate the steps. Circle the angle we have information about. B, 44 degrees. Identify the sides you have information about. This is the hypotenuse, and this side does not run into angle B, so it must be the opposite side. This side runs into angle B, so this is the adjacent side. Okay. Opposite hypotenuse, if you look at the ratio, opposite hypotenuse, those sides are used in the sine ratio. So I know this is sine of angle B, which is 44 degrees. Sine of the angle is equal to the ratio opposite over hypotenuse. Make this look like a true proportion. Cross multiply so you don't grab the x, and divide by what's left over. So when we type this in the calculator, 1 times 3, I could have just wrote 3 because I know that's 3. 3 divided by sine of 144. I'm sorry, sine of 44, I mean. Sine of 44. And there you go, you get 4.3. Okay. Pause it, I'm going to move on. Same thing. Identify which acute angle we have information about, and then label these sides. I know this one's the hypotenuse because it's across the 90-degree angle. I'm not going to put in hypotenuse because I don't have information about it, but that does tell me that, okay, one of these is opposite and the other one's adjacent. The 10 runs into angle A, so I know it's the adjacent angle. It's adjacent to the angle I know information about. And this one is the opposite leg because it's opposite that angle. It's across the angle. Opposite adjacent, there it is, opposite adjacent. The tan ratio uses opposite adjacent. So I know tangent of angle 62.7 degrees is equal to the ratio opposite. Put a 1 under it, cross multiply so we don't grab the x, divide by what's left over. Type that in the calculator. Tangent of 62.7 degrees, close that, times 10 divided by 1, 19.4. Pause it, then we got the last one.